The assumed average methodology is a very quick method of finding average, especially when the numbers that you have to find the average of are not small one digit numbers that whose computation you can do very quickly. So for look at this case. So we have these numbers 27, 26, 22, 23, 25. So while we could do the standard method of finding average, while we could add them up and divide the sum by 1, 2, 3, 4, 5, what we are going to do now is we are going to find the average using a much shorter methodology, and that methodology is assumed average, right? So what I'm going to do is I'm going to look at all of these numbers and I'm going to assume an average. So let's say we assume, let's say 25 as the average. Now clearly this is not the correct or possibly the final average of these numbers. But I noticed that the numbers 22 to 27, the 25 lies somewhere in between, and 25 is a number that I can quickly do my computations with. So I'll assume 25 as the average here, and what now I'm going to do is, so if each data point is xi, then I'm going to find how far away each data point is from the assumed average, right? So for 27, 27 minus 25 is 2 units, right? 26 minus 25 is 1. 22 minus 25, however, is negative 3. Please remember, you have to make sure that you get the sign right, okay? Then 23 minus 25 is minus 2. And 25 minus 25 is 0, right? So what we have done is, instead of finding out the 27 plus 26 plus 22 plus 23 plus 25, we are just finding out the distance of each of these data points from an assumed average, right? Now what this does for me is, instead of adding all of these points, now the sum total is going to be 25 multiplied by 5 plus these data points, right? Because this is actually what we are doing is we are expressing 27 as 25 plus 2. If you notice, what we are now doing is 25 plus 2. This is how we have represented 27. 26 is represented as 26 plus 1. 25 plus 1. 22 is represented as 25 minus 3. 23 is 25 minus 2, and 25 is 25 minus 0, right? So when I'm going to add these up, my sum total is going to be 25 times 5, right, plus sum of all of these numbers, right? So the sum total of these numbers is 2 and 1 3, negative 3 makes it 0, minus 2, right? So what I've done is I've very quickly added these numbers up. So if I add these numbers up, then so this is the sum total of these numbers, right? This is the sum of these numbers, 5 times 25 minus 2. So my actual average turns out to be 5 into 25 minus 2, which is the sum of these numbers, divided by the number of data points, which is 5, right? Now instead of just computing all of this, what I'm going to do is I'm going to split this up into two parts. So the average is actually 5 into 25 divided by 5 minus 2 by 5, right? So I notice that the number of the number of multiples of the assumed average, it gets cancelled by the number of data points. So the 5 cancels the 5 in this half, in this part of the computation, and we are left with the final answer as the assumed average minus this sum, right, which is negative 2, sorry, actually it's plus this sum, which is negative 2, divided by the number of data points, which is 5. So the answer is 25 minus 0.4, which is equal to 24.6, right? So clearly this is a much faster way of finding this, of doing the same computation. So what we've done is we've just simply assumed a number as the average, which we call as assumed average, and we find out how far away each data point is from the average. The answer, the actual answer, the average is the assumed average plus this sum, which is sum of xi minus the assumed average divided by the number of data points. So this makes it a much faster computation than adding each data points and then dividing the sum by the number of data entries.